We think we have a pretty good picture of how galaxies form. But what if? What if we've had the whole story backwards this entire time? Today, we're going to dig into a really wild, radical new theory about where galaxies come from, and it kind of turns everything we thought we knew completely on its head. So, let's get right into it.
Yeah, I mean, for decades, the story has always been this slow, patient, gradual thing, right? But what if that's just not the whole picture? What if the real story is way faster, way more dramatic? What if it doesn't start from the outside pulling things in, but from the very center, exploding out?
Okay, so let's really unpack this new galactic origin story. It's a direct challenge to what we call the standard model. It suggests a totally different way these incredible, massive structures are actually born.
So here's the fundamental difference, right? You've got two completely opposite ideas. On one side, there's the standard model, this outside-in story. It's all about slow, patient gravity, just pulling things together over billions and billions of years. But then you have the galaxy seed theory, and it's the exact opposite. It's an inside-out story, all driven by one single incredibly powerful event, a rupture right from the heart of it all.
Okay, so if we're going to understand this rupture, we need to rewind the clock. We've got to look at the system before the galaxy as we know it even existed. And according to this new idea, there were two main players on the stage, ready for the show to start. All right, first up, you've got what's called the seed. It's right there in the middle. Now, this isn't quite the supermassive black hole we talk about today. It's more of a precursor. They call it a condensed black hole, or CBH for short. And then, surrounding that seed, you have the sphere, just this huge reservoir of gas, dust, and really ancient stars. These two things, the seed and the sphere, are absolutely crucial. You gotta remember them. Now, that sphere, that surrounding cloud of stuff, this is where the theory gets really wild. We actually see that today. We call it the galactic halo. But here's the twist. Instead of being some leftover debris that got flung out from the galaxy, this theory says the halo was there first. It's what's left of that original sphere. It predates the galaxy itself. So, let that sink in for a second. The halo isn't made by the galaxy. The galaxy is born inside of its own halo. It means the halo is like this historical fingerprint, a memory of what the whole system was like before the main event even kicked off. Okay, so we've set the stage. Now let's get to the main event. The theory has a really cool name for it, blossom. This is the moment, the breaking point, when that central seed just can't take the pressure anymore, and it gives birth to the galaxy we see today. So you're probably asking, how does this actually happen? Well, that central seed just keeps gathering more and more material, right? Its gravitational pull gets deeper and stronger. The best analogy is to think of it like an overcompressed steel spring. You just keep pushing it, tighter and tighter, forcing it into this unsustainable state until, wham, it hits a physical limit, a point where it literally cannot be compressed any further. And that's the breaking point. The seed ruptures. Now, it's really important to get this next part. This is not a messy, chaotic explosion like you might be picturing. The theory is very specific that blossom is a structured release of all that matter and energy. It's shaped and guided by things like the seed's spin and all that material in the halo around it. And the sheer scale of this event, it's just mind-boggling. Get this, a provisional estimate suggests that up to 95% of the seed's mass gets blasted outwards during this blossom event. 95%. That means pretty much all the stuff that's going to make up the new galaxy gets released in this one single, incredibly powerful moment. Okay, so a big question probably just popped into your head, right? If it's this one type of event that creates galaxies, why on earth do they all look so different? Why do we get beautiful spirals, and then big, blobby ellipticals, and then ones with bars? Well, this is where the theory gets really elegant, where its power to explain things really shines. It all comes down to the geometry of that rupture. The way it happens dictates the final shape. So if you get a nice, clean, orderly release with a lot of spin, boom, you get a beautiful spiral galaxy. If the rupture is more lopsided and asymmetric, you end up with an elliptical. If the release is really concentrated out of two sides, you get a bar running through the middle. And, this is so cool, a ring galaxy? That's seen as a galaxy where blossom is still in progress. That ring is the active front of creation happening right now. Of course, any good scientific theory has to be testable, right? You can't just tell a good story. It has to make predictions that astronomers can actually go out and check with their telescopes. So, how can we actually test if this whole inside-out story is for real?
Well, the key is to think of a galaxy like a time map of its own birth. The theory predicts a very specific order of events, a chronology. The halo, that should be the oldest part, the ancient remnant. The main disk that we see, the spiral arms and so on, that should be younger. And in one of those ring galaxies, the ring itself should be the absolute youngest part of the whole system, because that's where the action is still happening.
And this gives us some really clear, testable predictions. I mean, things we can actually go out and measure. First, halos should pretty much always be older than their galactic planes. If we find that's true, that's a huge point for this theory. Second, in ring galaxies, the rings should be young, but the stuff above and below it, the halo, should be old. Another test? We can even check for things like thickening in asymmetric galaxies. Each one of these is like a clue, a way for us to try and read the galaxy's birth certificate.
So when you boil it all down, the galaxy seed theory changes how we look at a galaxy. It's not just a static structure. It's a historical record. It's a fossil of its own incredibly fast and violent birth. It suggests that the answers we're looking for, these huge cosmic questions, aren't just somewhere out there. They're written right into the fabric of the galaxies all around us. And it leaves you with this incredible question. If galaxies really are time maps, what other amazing stories are waiting in the stars, just waiting for us to figure out how to read them?